everyone. This is Ishwarya Goyal
And I'm Nilesh Agarwal.
from Towards Scaling Inference. Towards Scaling Inference is a place where you can learn about ML deployments from zero to scale. We are very excited to have Parth from Primer with us today. Thank you,
Hey,
Parth,
hi.
for joining us.
Thank you. It's a pleasure to be here.
Awesome. So a little bit about Parth. He's a seasoned technology leader with a vast experience in ML ops, distributed systems, and cloud technologies. At Primer, he's leading a diverse team that delivers foundational capabilities for data orchestration and storage, ML workflows, etc. Previously, he has also worked with Bloomberg. So, so again, Parth, we would like to start the interview first by understanding that what kind of use cases and business problems are you solving through AI?
Yeah, so currently at Primer, we operate within the NLP space, and we build ML models which help understand, analyze, and summarize information in unstructured documents. So it involves all kinds of NLP problems you can think of, from structured data extraction with entities and extracting structured like numbers, dates, and other form of structured data, to also doing topical and semantic analysis, such as sentiment analysis, picks on the document it released to write, and overviews from documents itself. So I think Primer, in terms of how we apply ML, spans the whole breadth of NLP problems. And we use this to be able to understand unstructured text information and be able to analyze and structure information first, and then compress and summarize information for our users. So they can spend more time in making decisions rather than reading and understanding textual information.
Got it, got it. And how do you currently, deploy these models in production? Like, do you work with managed services like Hugging Face or AWS, or have you built your own ML infrastructure from scratch? Would also like to understand your thoughts on the pros and cons of these approaches.
Yeah, so at Primer, currently we have our own solution for ML infrastructure. And we started early in this space, somewhere around 2019, where the space was still early and primitive. And while there were solutions out there to deploy models, and also in the open source side, for us, one of the things which was necessary was that ability to be able to deploy these solutions on our customer hosted side was an important aspect when we were considering different managed services, right?
Got it. No, that's
Yeah.
super helpful to understand. And since you were deploying these models on customer side, right? So before deployment, like, do you also do some quantization, or let's say conversion to a standard format, so that like, let's say ONNX or TensorRT, like, so that you get best inference, and then also have a standard in which you can deploy?
Yeah, I think this is something simple techniques like quantizing models and using just-in-time compilation, and recently have been looking more deeply into standard formats like ONNX runtimes, and being able to get an open format which runs, which can run on different runtimes to extract performance from those.
Got it. So no, just want to like again double tap a little bit more on like the like what led to this, like what triggered, let's say, a conversion or quantization. Like, what were the challenges that you were facing when you were not doing these kind of things?
So I think it's really around how much latency a model has, and what kind of. So I think we use to run models on. So in the case, started with doing techniques function as the transform model size increases, and we wanted to the use case quantization. I think ONNX runtimes comes into picture where we're looking at customs where we have to deploy these mod hardware which we might not have full control on. So those are the cases. I think quantization was inspired main latency characteristics which we wanted to. And ONNX runtime is surely for latency, but also considering the hardware on which we are going to run the models.
Got it. So, okay. So these were the two primary use
Yes,
cases.
and yeah, and I think maybe you can tell me more about like what are you like maybe in terms of quantization.
Yeah, no. So this was our question. I think a lot of folks like again these are optional part of the ML pipeline, right? So if you even don't quantize your ONNX model, you can still deploy machine learning, right? But what our experience have been is like converting it into like say a standard format like ONNX is super good when you have like the environment is very variable, right? Because then like ONNX has a lot wider support. You can run it in Triton
Yeah.
containers. You can run it in a lot more framework. We have seen TensorRT actually go with people who are more on the self-deployed option, because if you're going with that kind of a conversion, that's just optimized for performance, right? So there, the key element is not portability. There, the key element is more like, hey, like with the same GPU, can I run like more through output, or can I run like low latency systems, right? So
Yeah.
those have been our experience in like especially when we convert to ONNX or TensorRT.
Yeah, I think one of the things which is there is we focused on stream processing at Primer. So when we built our ML infrastructure, stream processing was an important piece on how we designed our solution. And one of the things which was there was we had to figure out how to make sure that the pre and post processing steps, particularly in NLP, where the pre and post processing step could be quite involved in terms of how do you take a document, how do you break it down, how do you segment it, and how do you aggregate the results later on. Have a lot of business logic involved in that. And so we needed to also figure out then how do you manage that computation along with something which would just optimize for the graph execution itself. And so those were some of the consideration from an operational execution perspective on how do we create developer workflows for our data scientists to be able to leverage this optimization platform and also be able to take care of the pre and post processing. And we did analyze using Triton for our use case when we already had something which was working was kind of one of the challenges which we have had, right? So while latency is certainly something which we care about, we are also trying to balance between the operational cost from our developers' perspective on how do we make it something really simple for them to deploy models quickly.
Got it. So in that case, if I understand correctly, you thought that like creating an infrastructure with Triton was a bit limiting, especially because of the factor that it asks you to convert models into a particular format that it accepts, right? Whereas other serving like TF serving and like PyTorch and all those things, they allow you a native way where you can just like run the model, like just call runtime.run, right? Something like that.
Yeah, and I think like initially when we started, these technology sets were not as mature in terms of the feature capabilities which we wanted to use, and that's why we started something simple on our side, and that's something which has worked out well for us in terms of what our serving needs are, and particularly on the stream processing side. The solution which we have is pretty stable and reliable. And then I think it was also like, again, being able to interoperate for customer hosted and our SaaS solution was an important aspect in some of the choices which we made.
Got it. No, this is super interesting to hear that, like, again, like, what I understand is like your org always like there's a dev productivity. So dev should not be just doing like infrastructure stuff. So there should be like movement in what you expect as a business outcome. And then there's a balance of that versus like how efficiently can you deploy, right? Is that a correct understanding?
Yeah, and I think we have actually done quite a bit of work. The API is very simple. It's integrated into their GitHub workflow, so they can have change management, and you can always deploy really easily. And then we have like monitoring tools which are built in, which make it really easy to monitor once things are deployed.
And you were just talking a little bit about the streaming use cases that you have built, right? So the pre-processing and the post-processing unit. So can you just like talk a little bit more on like what was the scenario where you needed streaming, and like then what were the challenges that when you like build the system first time, like maybe it could be compatibility with the serving framework or like something around that. Yeah.
Yeah, I think I think for us, we process data in streaming fashion.
Okay.
We work with open source data such as mainstream media content and also social media content, which is streaming in nature. So we wanted something which instead of just being like a REST API, could provide a more streaming interface to running models, right? And so for us, you can think about a request comes in, it gets queued up, and then it runs the inference on a GPU, and the results would also be pushed to a queue, right? And like there are different flavors on how our API works, but stream processing was pretty important for us. And so we have optimized the system around it and tried to make sure that there are abstractions from a user perspective where they do not really need to know how the model is running. And I think some of it is also like where you said uh, it's very functional in nature, where the user does not need to know anything about the infrastructure. And then the pre and post processing right now is packaged with the model itself, where the customer can define whatever pre and post processing they need. Um, can we optimize that further? Can we like really separate out the CPU and GPU processing to a level where we can get more out of the GPUs? We could, but I think one of the things which is there is for the kind of scale and latency characteristics which we need, it's a good balance between how much we want to add operational complexity from a development perspective versus how much we want to kind of get more performance out of the GPUs itself.
Got it. No, that's super helpful and I think very brief. So just as you said, like everything more works more as a functional service, right? So did you guys also explore like serverless GPU deployment where like you don't have to worry about that also? If you have any experience in that, would love to like model.
Right, we wanted to be easily deployable on the customer side also. So we chose Kubernetes as our common abstraction layer to build our stuff, right? And we have invested heavily in terms of usage-based GPU utilization with auto scaling setup and everything. So it behaves very serverless and functional to our customers itself. We ended up building it ourselves because that was an organic evolution of our solution over time. But initially started with not all the bells and whistles, but really focused on building something simple which works reliably and is integrated into the workflows. And then to me, GPU utilization and things which enable you to kind of really scale your resources based on usage is an optimization problem, which is easier to do if you have good adoption and a common API contract which customers are already using.
Got it, got it. And like, would you have any numbers on the band? Again, it's confidential. You can like keep it to yourself. Like,
Yeah.
what is your average GPU utilization like across clusters, across everything?
Yeah, I think that number has been changing over time. I think we have been trying to get more and more out of our GPUs. It depends on the models also, right? I think one of the things which is there is while I do not have an exact number for you, but I probably have some characteristics. So for models which are like take a long time on GPUs, right? Particularly models which have in the higher order of hundreds of millions of parameters versus models which are smaller. Um, if you're spending more time on GPU, you see naturally high utilization on GPUs, right? So there is also a skew on like the time it takes for inference request per model, which kind of naturally skews utilization. Um, but yeah, I think for us, I probably do not have the exact numbers to share with you on this right now. But what I would say is that things which we do also is bin pack models on a GPU to maximize utilization, right? And I think for us, those are the things which have been really effective in packing models effectively on GPUs. to maximize both the memory and the actual
Inference.
execution utilization of the GPU itself.
Got it. No, this is super interesting, and I have seen very like few organization during like our interviews who've actually like using bin packing on GPUs. So I think that's pretty amazing to hear that. And
Yep.
then I'm assuming since you have done all of these, so you must have written your own containers, right? Where like all of the like how a model is pulled and like the container manages the GPU resources and everything.
Yeah. So again, I think this is another area where over time we have invested in developer tooling around this, where it's both we would have our own containers, or our internal teams can bring their own containers also, and we provide them developer tooling with the libraries which are needed to make, in some ways, the runtime which can actually run on our platform right now, right?
Got it. Got it.
So you can build your own container image by embedding our runtime toolkit with your model itself, and everything would just work.
Got it. No, this is also pretty good that again you guys have reached to that sophistication. Got it.
Yeah.
So yeah, between and just the next question on like latency versus accuracy, right? So again,
Yep.
like there are different models which are of like multi-million or even billions of parameters, right? Which can get you super good accuracy. Versus there are models which are like lesser in size, easier to execute, but may not be super accurate, right? So how do you go about like strategy of like, okay, what should this model size be, or is that a constraint? Or is latency a constraint to design the model like Swift?
I think I would say that at Primer, in my current company, we have been focused on accuracy and model performance in most parts at the trade-off of latency so far. I think for us, one of the things which is there is our use cases and the way we process information. I think we have had not as many cases where we had to make this trade-off, and accuracy is still paramount for us. I think in terms of like things which we have done to kind of make that trade-offs better, is sometimes like I think when you talk about running your model on customer hosted solutions where you do not get the same hardware if you were to run it on SaaS, are techniques which allow you to the thing which we call inference triage, where the concept is that can you train a cheaper model to do the same task and then leverage the heavy model, or in some ways the model which is more accurate but slower only when you really need it, right? And so the concept is uh, to use a cheaper, faster model for probably 90% of the cases, and have a system where you can triage the request based on confidence of the cheaper model to decide when you want to use the heavier, more expensive model. And so we have invested in these kind of techniques from a research perspective. And so in some ways that helps us make trade-offs. But our trade-off is not to like retrain a smaller model and do that comparison, but more like, can we get the best of both worlds in some ways where we would train a smaller model. And it's true, right? A lot of times a small model can do the job and you need the bigger model for cases which are really tricky and hard. And if you can build a system which can truly identify this well, you can get benefits of both.
Oh, this is super interesting.
Got it. Finally, I think what we would like to also understand that can you discuss any best practices or tips for other ML engineers who are looking to, deploy their models in production based on your experience?
Yeah, I guess maybe one question. Are you looking for advice from a perspective of someone building a solution or someone trying to deploy a model? Someone building a
Someone
solution.
who's looking to deploy, yeah.
Yeah. I think someone who is looking to deploy a model on production, right? I think just a good rule of thumb is that you don't always have to train a transformer. I think it's a good practice to train a non-transformer model and benchmark your results. General ML practice is to always have a test set to validate the performance of your model. And I think you should define your success of the model before actually even starting the project. Like, what is the data set you are going to test the model itself? And in terms of the deployment itself, right? It depends what the company constraints are. But one suggestion which I have is incorporating deployment of models and how the model was trained as a part of some workflow which allows you to reproduce the results is an important aspect, because I think one of the challenges with ML workflows is that it's a very iterative one, and you probably change 1 or 2 data points here and there to kind of test performance again, and that could mean you lose that lineage of how did you reach here. And so there are good tools for experiment tracking, and which is kind of similar to Git workflows for model development workflows, which are handy in these cases. And yeah, so don't always need to train the most latest deep neural network model. Always good to connect with a simpler model and see if this just fits the bill which you want. Make sure you understand what the customer needs are, and make sure you have a test representative data set to validate your model on the end problem which you're trying to solve. And then when deploying the model, keep reproducibility in mind, both on the training side and if you can, depends if you want to use a leverage, if you want to use a managed service and you're just starting, I think those are great because you don't need to spin up infrastructure and use those. Make sure that you have some way to kind of keep track of the models which are deployed and a good monitoring system. I think if you are really trying to scale your deployments of models, having visibility into how the models are getting called and what the GPU utilization is important. You can think of model monitoring itself, but I think software performance monitoring is also an important aspect.
Got it, got it. No, definitely. I think all these points are, I'm sure this is going to be very beneficial for folks who are currently looking to, deploy their models in production. So yeah, Parth, I think this is it from our side. Thank you so much once again for taking
Yeah,
out
for
time
sure.
for the call. And I personally, I think, enjoyed this a lot. So thanks once
Yeah,
again.
for sure.